Okay, folks, I'm going to, like I promised you, I'm going to do a YouTube video for you you don't have to come to class today. This is August 23rd, 2013. Here is what we're going to talk about. Remember, we talked about CIA already, right? We talked about CIA, we talked about confidentiality, right? We talked about confidentiality is achieved by encryption, right? Talked about the different ways you can encrypt, public key, private key, and so on. We talked about I. This is the C. This is the I for integrity. We talked about hashing. And I said we were going to talk about A, which is availability. Availability is divided into three components, right? AAA, and I think we mentioned that already. The first A is for authentication. Right? The second A is for authorization. And the third A is for auditing. Right? I don't know if you remember that, but we talked about those. We briefly mentioned those, right, last time. So let's look at authentication, right? Authentication means the system has to recognize you as a user. That does not mean you have access to anything, right? So, for example, we talked about this. You can come into the Y building, but doesn't mean you can attend classes, right? This is just authentication. On systems, how do we authenticate? The easiest method that we are familiar with is use a username and a password, right? Most of us, it's something we know. We know something. We know. We remember our password, and we use it, right? If we don't remember our password, if we don't know it, we cannot enter the system. Now, remote authentication uses a couple of protocols here. PAP, Password Authentication Protocol. PAP is not that great. It is a clear text protocol. Clear text, right? It's not that efficient because somebody can see what you are sending over the network, right? The second one is CHAP. A little bit different in the sense that here it stands for Challenge and Response Authentication Protocol. Challenge and response. Right? Challenge and response, what it does, you enter your username and password. So username, right? For example, you're sitting in front of a machine. You enter your username, and then you put in your password. Right? What it does, it uses these two to generate a token. And the token is sent across the network to the server. The server has your username and password already because you probably enroll at some point. It looks at your username and password and generate a token. Okay, so this is you. You access the server, right? So here you enter your username, name, password, right? So it does all of this and send the token on here. This is your server. Your server has your username already because you have had to enroll at some point, your password, and it would look at this and say, okay, do I have this user? If you don't have the user, I would say user not found. And if it does have the user, now I need to check the password. So it does the same, use the same algorithm to come up with a token. So it comes up with a token here. So then it compares the two tokens. That's the challenge. And if they are identical, so it will give you access to the network. So to have a successful authentication, the token that is being sent has to be the same as the token that is generated by the server. Okay, this is challenge and response. This is the one that was used by that has been used by Windows for a long time. The problem with this is, right, you can log into the system in the morning. In the afternoon you get fired for some reason or another, and it does not go back. There's no time factor to it, so it doesn't go back and see if you are still a user on the system. Now the current method is called Kerberos. Kerberos is like a movie theater, right? You buy a ticket for a show at a certain time. So here, in order to access a resource, you need to have a permission, right? And the permission is valid for a certain time, period of time, right? And it constantly will go back and check if you still have your credential. For example, if you go to a movie theater, you buy a ticket for the 2 o'clock show, and you don't show up until the 3 o'clock show, and you want to go see another movie. It doesn't let you in. Well, it's not supposed to, right? So that's Kerberos. Kerberos is used by Unix, has been around for a while, Unix and Windows, right? This is the current way that most system actually uses it. So it's very efficient, right? Very efficient. Not only it meets the basic requirement, it has the time factor, and it actually lets you in, right? And it does go back and check if you're still a user on the system, as opposed to the other method. The other method, once you're in for the duration, of the session. So if you leave and you come back a couple of days later, nothing has happened to the system, you're still on the system, right? So there is also a protocol called EAP, right? EAP actually is a little bit better because it works at the lower part of the OSI model at layer 2. It doesn't need, it does not need an IP network to function. It can function at a lower layer, so it is a little bit more flexible. You can use biometric and so on with EAP. Let's talk a little bit about biometric. You are probably familiar with biometric, and you have heard of biometric already, because you probably have a laptop that has biometric on it. There are different methodology for biometric. There are different algorithms. Most of us are familiar with fingerprinting, right? You probably know fingerprinting. There's also retina scan. There's also, what do we call that, iris scan, right? Hand geometry. So you put your hand on this reader, and then the reader will actually read your hand, and if it meets the requirement, it will authenticate you. There's also facial recognition, right? This is a passive one, so you don't have to do anything. It is in the crowd, and it can recognize your face based on prior registration process. It has a face that matches yours, so it can recognize your face. There are a lot of there are new ones called odor recognition. It recognizes your body odor, right? if your body odor is, matches. Remember, dogs can smell very low level body odor, and then it can recognize it based on that. Right, so there are a lot of things going on with using biometric for authentication. It's a developing area, right? So we'll come. We'll probably have more on this in other courses if you decide to take other courses. Now, what else? Also, remember you have digital IDs, right, that you can use. A lot of us carry a digital card, and once you have your digital card, you enter that number that is in the digital card on the system, and it will recognize you based on that. So you remember the concept is something you know, something you have, and something you are. Something you know, password. Something you have is your digital card, and something you are is biometric system. So let me stop this right here, and I'll continue with another clip because I think if it's too large, it won't let me load it. Okay?